So we have discussed about why it is required, the finite element method. We have got the governing equations on the domain, and to solve that equation is difficult if it is boundary is difficult, and the shape of the structure is difficult, so that the general solution cannot be obtained. Hence, what is done is that the whole domain where we require to solve these differential equations are divided into small parts called the elements, and subdivide the domain of the solid, which subdivide the domain of the solids. The element assemble through interconnections at a finite number of points, nodes on each element. So when this whole structure is divided into different elements, the elements are connected at the nodes, and the assembly provides a model of the structures. So here it is shown in figure, the whole domain is divided into elements which are interconnected by dots. Those dots are nothing but the nodes, and element is bounded by rectangular element or triangular element. Different type of elements can be created, and this loading and the boundary conditions, the supports, they are also has to be defined in the different elements where these are encountered in the loads and the supports. Within each small domain, we assume a simple general solution to the governing equations. Solution for each element is a function of the unknown solution at the nodes. What is the fundamental conception? First, domain. Suppose let us take a bar or a beam which is fixed at one end, and x coordinate is given in the x direction. The beam is called domain. So here it is infinite degrees of freedom. Then we divide these infinite degrees of freedom into finite number of subdomains, which is connected at nodes, and the deflections or whatever it may be, other functions are defined within the element. Then this continuous function of a continuum having infinite degree of freedom is replaced by discrete model approximated by a set of piecewise continuous functions having a finite degree of freedom. Discrete model has finite degree of freedom, hence method got the name finite elements, and which is coined by Clough in 1960. Application of the general solution to all the elements results finite set of algebraic equations which are solved for the unknown nodal values phi. The equation is k phi equal to f. F is the applied load. Applying boundary, k is the stiffness, phi is the value, that is unknown values, maybe nodal displacements, or in heat transfer it may be temperature. Applying boundary conditions, the solutions for phi is obtained. General overview, again the sources of error. The assumed solution within the element is rarely the exact solution, hence the error may come. Error between exact and assumed solution is one of the error. Magnitude depends on the size of the elements relative to the solution variations. In most cases, assumed solution converges to the correct as element size decreases. This all solid structures could be modeled with three-dimensional solid elements, but for many cases this is overkill. Many structures can be simplified by making some assumption, plane stress, plane strain assumption, simple beam theory. When the elements are categorized as either structural or continuum, Structural elements include trusses, beams, plates, and shells. Formulations are based on same assumption as in their structural theories. Finite element solution is no more accurate than the solution using conventional beam or plate theory. Continuum elements are 2 or 3-dimensional solid elements. Formulation based on theory of elasticity, which provides the governing equation for deformation and stresses. And closed form numerical solution is be difficult to find on those problems. Hence we go for the finite element. And this whole process is computer program is created in 3 stages. First is pre-processing, that is we have to decide what type of elements we have to take, which type of node connections, what are the equations. Then processor, the equation solution, the algebraic equation that will be generated and will be solved in the processor. Then post-processing, because the unknown will be either displacement or temperature, and other values can be calculated like stresses and other things, strains. This can be calculated in the post-processing.